Good afternoon and welcome to the Remodelers Council webinar. Today's webinar is Ventilation 101 and it is presented by Michael Mann from Shady Oak Distributing. Anytime you have a question, there is a chat box or a question. You can raise your hand and then I'll watch and let Michael know when there's a question. My name is John Eischen with the Rush Rebuilders. So welcome, and Michael, I'm going to turn it over to you.
Awesome. Thanks, John. And thanks everybody for stepping in today. This is everybody's favorite subject. I'm joking, of course. Ventilation 101. This comes from my experience 30 years in the kitchen industry at almost every level in the appliance end, also working with a lot of builders and remodelers and designers and architects. And it's my goal to help you wrap your head around a little bit more the impact ventilation can have in a positive way and a negative way, depending on how it's done in any project, be it a new home build or be it a remodel. It is IDCEC approved. So if you need approval through the IDCEC, get me a note and I will take care of that for you. You can also self-report if you're a member of NKBA, AIA, or other organizations that allow self-reporting. This is what I'm hoping to come out the other end with, get you a basic understanding of kitchen ventilation, how you can expect the different types of ventilation to work, the consequences of location and improper installation, and really the most important thing is the impact ventilation can have on what I call a successful kitchen project. In other words, 1 year, 3 years out in the home, the homeowner, the client is really happy with everything that's going on and their smoke alarms aren't going off. So start with this because this is something nobody's really said ever, hardly, that people highly value kitchen ventilation because it works. Most people don't expect it to work. They've never experienced good kitchen ventilation. The good news is it can be done. It isn't always easy and sometimes it's expensive, but it's also good to know what it takes. So if nothing else, you can adjust expectations accordingly. As builders, remodelers, architects, designers, we all have a great impact on how this can turn out. And I'm going to start really very basic, just because it's good to set the base level. So what is a range hood? This is from Wikipedia. I think we probably all kind of know what it is, but really it's there. It's a fan system that's there to exhaust products from the kitchen to the exterior of the home. That's its main goal. It also is there to trap grease, and most will vent to the outside. That's what we like, but there are recirculating or ductless hoods, which I'll cover in this as well. So really what ventilation is for, and proper ventilation, it solves a problem. And the problem is air quality in the home. This comes from some work that's being done in Berkeley. They're doing a lot of work in California right now around air quality in the home. And it doesn't just focus on the kitchen. However, this is one thing that came out of that in 60% of the homes, cooking once a week, you're reaching pollutant levels in the home that would be illegal. It's illegal in California if found outdoors. This one really jumped out at me too. That was from a different study, but the fact that the level of cooking contaminants in the home can raise the particulate matter to concentrations 4 times greater than hazy vents in Beijing. We know how bad that is. So the air quality in the home is becoming a bigger and a bigger deal. At some point, I fully expect to see more requirements on what one does with tighter homes, things like off-gassing of even flooring, paint, new furniture. There's a lot more coming out on whole home ventilation. I'm obviously going to be concentrating on what happens in the kitchen. And this is what we're really trying to avoid. You know, and what this Jennifer found, and this is very true, experiential for me in 30 years, most people are used to the smell, so they don't realize it's an issue. To my initial thing, have people said they highly value ventilation because it works great and they love it? Not very often, but they've never experienced it. More typical is that they've had food smells in the home because their ventilation doesn't work very well. Part of the reason is they don't use it. And a lot of the hoods maybe aren't very effective. So you're going to have a problem with a lot of pollutants in the home. If you smell bacon in your garage or your bedroom, your ventilation isn't working very well. So backing right up to what is the purpose? So specifically, it's to increase the indoor air quality by removing the cooking contaminants before they mix with the rest of the air in the home. And what are those? This is what we're trying to deal with. We've got heat, which is something very difficult to get out of the house if you recirculate. Steam, smoke, odor, and hazardous gases. All of those units are things we want to remove from the home. The one thing we do want to intercept and remove from the airstream and capture it in a place we can clean it is the one on the bottom, which is grease. So this is the problem we're trying to deal with. Again, in my experience, especially when dealing with a higher end home where we're likely dealing with much larger cooking equipment, the selection of the ventilation equipment is as important as that of the cooking equipment. When I've worked one-on-one with clients, if we're looking at larger cooking equipment, frequently I will start with the ventilation as opposed to leaving it to the end, because I understand how much this can impact. You know, they're looking at a $15,000 range. I want them to enjoy using it. We need to talk about properly ventilating it, or that's going to really affect their enjoyment, not only of the equipment, but of their entire project. And there's several categories of ventilation. I've broken them down into basically 4. Ductless hoods or recirculating hoods, which are not preferred because obviously you can't remove things from the home if they recirculate in, but they're there. Sometimes you have to use them. There are downdrafts, which have been around for quite a while. They're the downdrafts that either are at the same level as the cooking equipment, or more frequently now you're seeing an increase in availability of the downdrafts that raise up behind the cooking equipment. Most all hoods, with one exception, are going to be hoods that have a filter bank of them in them of some kind. And there are hoods out there that in lieu of filters use what they call a centrifugal blower. They're basically a centrifuge. So I kind of touch on a little bit of all of these. So let's think about, how do you actually achieve good ventilation? There's 3 main components to effective ventilation. There's what I refer to as the canopy. So that's really the hood. And that's the part that you see that captures everything. At some point in the run, there's going to be some blower units that move the air. We have to move the air and help it move somewhere. Even if we're recirculating, there's going to be a blower unit in there somewhere. And when we do duct to the outside, there's going to be ductwork that connects to the whole system. Of these 3, they all kind of have to line up. The one that is the bugaboo frequently is the last one, ducting. The one we can really control at the front end is the first 2 units. And that's where, when you're working with the client, your recommendations come into play. You can also affect the ducting if you're involved in the design, because where you place the unit really will affect how easily it is going to be to duct it properly. And I'll focus on all 3 of these things separately. So let's start with the canopy. So I call this the part you usually see. You can see here we've got a couple standard wall hoods. The black one in the left corner is sometimes one of the recirculating hoods. The one on the bottom is kind of a new piece that goes way up in the ceiling. They're designed to be in islands predominantly. The one on the right is referred to as a custom, sometimes a built-in or a liner. And even though the cabinet maker is making the part that you see, there's still a canopy underneath there that's the functional part of the hood. When it comes to some hood styles, there's really 2 pieces to it. There is what I'm calling the canopy. And in addition to the part that you see, the canopy is also where the hood is going to capture the contaminants, hopefully, that are coming up off the cooking equipment. And then in the case of a chimney style hood on the left, there's usually a duct cover involved, and it's aptly named because it literally covers up the duct run as it comes out of the hood. Many hoods, especially larger hoods, are going to duct out of the top before you can start to change direction. Some smaller hoods will allow you to vent directly out of the back, but frequently you're going to have to go out the top. So that's why there are duct covers available, even in some pro style hoods like you see on the right. So part of understanding how we achieve good ventilation is thinking and understanding what's happening when you cook. The canopy is there to do a job, and this is generally agreed upon that even if you cook just one day a week, you're going to generate about a gallon of grease a year, and it goes somewhere. So ventilation is important. We really would like to capture that and keep it in a place where we can clean it out, as opposed to allowing it to filter out to the rest of the house and end up on our walls and our cabinets, maybe even in our couch and our drapery in the other room. So one way to think about canopies is think of it as an inverted bucket, an upside down bucket that's there to capture everything that's pouring out of the cooking equipment and whatever the products are that we're cooking. Now, gas is the one that is going to add to the pollutant levels that we have, because there's some off-gassing, and the way heat works off gas stoves is pretty aggressive, and it comes up at a pretty good rate. Again, I noticed this earlier, we're reaching pollutant levels that in California would be illegal if found outdoors. So we're trying to handle a pretty significant problem. And this is what happens when you're cooking. Cooking contaminants don't just go straight up. They actually start to expand right away as you cook. They'll go out to the left and the right, and they'll actually come out towards the front as well. So in a best case, we would like a hood to overlap, and every hood manufacturer will agree on this. And a lot of architects will also design this in, those who understand it well. It does affect your upper cabinets, but by overlapping by 3 inches on each side, we're going to be able to capture everything as opposed to having things leak outside. If you look at the red line, that's what we want to avoid. So the overlap is really important. Now, most hoods are designed to be okay matching the width of the product that they're over. So 36-inch hood over 36 inches, 48 over 48, 30 over 30. But we know we'll do a better job. We'll be able to do a better job if we can overlap by at least 3 inches on each side. Same thing with what we call the projection. And every hood is designed and engineered to expecting to go over a certain type of cooking equipment. For example, a hood that's engineered to go over a regular cooktop or maybe an electric range is going to project somewhere in the neighborhood of 20 inches, because those tend to sit back further. So our goal is to cover it all the way out to the edge of the front burner. When you look at a hood that's engineered to go over professional style cooking, like the big Wolf ranges or the Jenn-Air or Dacor or Thermadors, they're going to be deeper right out of the gate from front to back, because those burners, for one, sit out further. And because they generate so much heat, your mounting height is going to be higher on the hood. Bearing in mind, all of this cooking is expanding to the left and the right and out the front. We want to be able to capture that, because we don't want that red line to happen. Hoods won't suck in from out there. Where you see that red arrow, once it's out there, it's going in the rest of the house or the room or wherever it's going to migrate to. The hood isn't going to suck it back in, even if it's 1200 CFM. Hoods just don't draw like that. They need to be over the cooking equipment to be able to capture what's going on underneath. And I just mentioned mounting height. That is also very crucial. Frequently when I'm out, and I do this, I go out to homes if people think their hoods aren't working correctly. Frequently I will see hoods that are mounted higher than the engineers planned on them to be able to work well. There's a brand out there that knows how well their hoods work well enough that if it's done right, they will guarantee that it works. But once you get too high, as I was mentioning before, you start losing your ability to capture, because everything's expanding outside of the capture area of the hood. Mounting height for regular cooktops, regular ranges, hoods intending to go over that tend to be between 24 and 27 inches, whereas pro style hoods, and actually I'll be honest, where people most likely want to mount it, what feels comfortable, is about 30 inches. Some manufacturers will say in their installation that you can mount it as high as 36. However, if you talk to their engineers, they know that at 36 inches, unless the hood starts to get really big front to back and unless it's overlapping. At 36 and anything above that, it's going to be very difficult for it to start to capture anything. It'll get stuff from the middle and from maybe the back if we're against a wall, but mounting height is pretty critical. And again, it's dependent on the engineering of the hood and what it's intended to go over and how it's intended to be installed. There's help out there to determine that on the front end. These are some examples of mounting height recommendations where in literature or on websites. The one on the upper left is from Zephyr. They do a nice job as you move your cursor on the left up and down for your ceiling height, it'll start telling you, what type of extension you need and all that kind of thing. And you'll see right there, they have mounting heights listed, 26 to 34 standard, et cetera, et cetera. On the upper right are two where you have an example of a standard hood, one expecting to go over standard cooking at 24 to 27, and something that's going to be creating more of a problem like a pro piece of cooking equipment where we're at a 30-inch mounting height. Holding capacity is something that gets talked about frequently, and it really differs on a lot of hoods. Most filtered hoods, which are a bulk of them, don't have a lot of holding capacity, so they'll use air movement to make up for it. But to collect the cooking vapors, the holding capacity needs to be equivalent to what we're putting it over. That's why an example on the left, you'll see much smaller hoods, some 6 inches, some 9 inches in height, which are intended to be able to hold what's going again with standard cooking equipment. Whereas when you move over to pro style, and I'm sure you've seen this, those hoods tend to be 18 to 30 inches in height, as they need more holding capacity, more capability to be able to handle this bigger problem that the pro cooking is providing and giving us. Also, there are different hood styles that are based on where you're going to install them. So here's a smattering of types of installations that happen out there. The best case is wall installations. We like that because the wall will help us contain the cooking contaminants. That back wall takes care of a lot of the problem and helps us control where everything's going. And that's one that you probably see most frequently. Right underneath that is the under cabinet. That's where you'll see sometimes the over-the-range microwaves will go in there, the small 6-inch hoods. Frequently, that's where the bulk of the recirculating or ductless hoods will be. The second to the right on the top is the most difficult scenario to properly ventilate, which is an island. Because we have no back wall to help us, we have a lot of possibility for air to disrupt the delivery of all the contaminants up into the hood canopy. In islands, you always need to get your hood bigger, wider, as wide as possible and as deep as possible front to back. The one in the middle corner, I saw that a lot more in the late 80s, early 90s. I think a lot of people have realized that's really a waste of space when you start putting things in the corner. Don't see that as often anymore, but they're still out there. The built-in is, again, the one that frequently you'll see called liners, custom. That's where your cabinet maker is going to provide what you see on the exterior. The hood itself might be a power pack, or it might be a full liner that has the blowers and everything that's going to go up in the cabinetry. Ceiling mounted are the newer ones. I think Best started that one, and that's where they have, and I'll touch on this in a second, the perimeter parametric hoods that go all the way up in the ceiling. The idea is there you can put them over an island situation and not have anything blocking your view. The problem with that is those cooking contaminants have to somehow get all the way up to where that is. And in a 10-foot high ceiling, believe it's going to be tough for them to get up there. Now, the ones that do, it will capture and pull through. But a lot of that is going to wander out through the room. Even as your air conditioner heating turns on, it'll create air eddies and that are going to move things around. And then the bottom second one on the right, downdrafts, those were generated when a lot of cooking was moved into islands and they didn't want island hoods, and the ceiling or parametric hoods didn't exist yet. So you saw pioneered by Thermador, the pop-up downdraft in the back, and also Jenn-Air, where their downdraft went right in either the cooktop or the range itself. I mentioned the liners, inserts, power packs. I kind of call this a canopy subset, and you'll see this done various ways. Top left is one that frequently will be called maybe a power pack. And if you look over on the right, you'll see one put in as well with a liner around it. Second to the left is what some manufacturers do call their liner. They will take a power pack that is 24 inches wide, about 12, maybe 18 inches deep at most. That will fit up in that empty rectangle. And then the liner itself is meant to flush out to 30, 36, sometimes 40 inches, just to cover up all of the wood that is going to be around the perimeter of the power pack. The second one in from the left is one of the parametric style power packs. I'm seeing these put in mostly right into the cabinetry, which I find surprising because there's now wood over the cooking equipment, which a lot of areas won't allow you to do. I think Rochester is up on that. Bottom left is a liner that happens to be a Vent-A-Hood liner, and that is basically all of the equipment, the blowers and everything, and you can put whatever you want around that. As you can see there, it happens to be tile, it could be wood. You could make something that looks like a whale and put a liner up inside of it. Bottom right is what you see from a lot of manufacturers for their pro liners. So you've got the baffles, a little bit of capture area. Those will usually be engineered to be over the 36 or 48 or maybe even 60-inch pro cooking equipment. And I mentioned these perimeter or parametric style hoods. These are a relative new entry into ventilation. And you can see their idea is you can put this up in the ceiling and now you have a really open area over your island cooking. Again, I have not seen these work really well with getting everything. It does get what gets up to them, but we have to get those cooking contaminants up to that for it to be able to do anything. Actually had a set of these. I was with Fisher and Paykel for 10 years, and we had them in our New York working kitchen. They were limited in CFM, so that really affected their ability to do much. And the room filled up a little bit. It was tough for stuff to get up there, but it does tick the box for having ventilation in there. And even though they look nice and clean, as you can see in the bottom left, these are a filtered hood. So as you see in the upper right and that picture in the middle, those panels flip down and behind them are pretty standard filters that need to be cleaned. Now, when I look at the one in the bottom, or the top right, the question always comes to, I know that people don't tend to clean their filters frequently when their hood is directly in front of them, right over their range. I'm gonna have to have a big ladder to get up and go open that up and pull my filters out to clean them. Likely not gonna happen very often unless you have somebody on staff to go do that for you, but that's the idea with them. And again, if you look in the bottom right, the idea is we can get those at, they'll say 48 to 72 inches above the cooking surface. But again, reality is the cooking contaminants have to get up there and not go anywhere else for it to be able to do its job. But they are out there. And when I look at hoods, and this is where I hope to help people get to, I can look at a hood and have an idea of how well it's going to work and what it's going to do. And one thing I do look for is how big is the bucket? Does it have a big bucket? Most ventilation today does not. And you'll notice, with the exception of one at the upper right, most of these are very flat. So they really don't have holding capacity. What they're going to do is they're going to rely on whatever blower system they have to try to pull everything through the flat filter system. Excuse me. Now on the plus end, one thing people will like about these is cleaning. It's easy to just wipe off that little bit of area around the filters and pop the filters in a dishwasher. So that's a benefit there. Excuse me again. You'll notice in the bottom right, really cool looking hood, possibly recirculating because there are fins at the top. Some island hoods even you can recirculate, but that one's gonna have a hard time catching everything because it is very flat. And it's also probably installed a little bit high. Downdrafts really don't have any holding capacity, so they are going to depend on air movement to redirect the cooking vapors into their into their fan system and down through their filter system. And here's an example of what I call extreme holding capacity. When you go into a commercial kitchen, you'll notice, if you look at this and look at above where they're cooking, you'll notice a couple things. And I like to point this out, not just for ventilation, but other things that I see. For one, you're seeing more induction in commercial kitchens because they don't generate as much heat. So that's nice. We don't have to deal with that very much. If you look up at the hood, you'll notice the capture area for that hood goes all the way back over the heads of whoever's going to be standing there cooking. The other thing you'll notice if you look at the far end, that's actually a grill. And you'll notice what it doesn't have on it, which is a canopy or a hood like you do on your outdoor cooking equipment. I'm seeing more and more people attempting to put outdoor grills with hoods on them inside their home or three-season porch, which does not work, and you can't ventilate it well, and they run into issues. If somebody wants to do something like that, from a ventilation perspective, we would like to see a manufacturer. There's a couple out there who make flat grills that don't have the hood that drops over to push the smoke all over the place. So that's easier to ventilate. But this is an example of holding capacity done incredibly well, but that's also because it's commercial. We're usually not going to be doing this in a residential home. So a lot of the holding capacity and everything has to do with capturing and removing the heat, the steam, the smoke, the odor, and any hazardous gases and evacuating them from the home. The one thing that we do want to capture again out of that airstream and capture it somewhere we can clean it is the grease, because we really don't want the grease to be in our duct run. We also don't want it to get through the rest of the house. Duct run can be tricky because if something goes wrong, over time, grease can build up in a duct run. Bugs like it, so they'll be in there. It'll collect up dust, particulates. They actually have a word for it. It's called mung. And that can become flammable in the duct run over time. So we don't like that. So let's talk about filters, since that's what the bulk of the hoods out there have. The filters are there to pull the grease out. And the basic idea of a filter is air will find its way from one side of the filter to the other. If we can make it find a different path and create a zigzag pattern for it to have to go through, the grease particles are heavier. So hopefully a lot of those grease particles will stick to the filter before they get to the other side and intercept that grease. So now we can capture them in the filter, take that out, and be able to clean that out of there. The issue with that, sometimes they lose their efficiency the more they do their job. Obviously, as that screen or whatever it is fills up, we're going to lose our effectiveness at removing the grease, and we're actually going to slow down the airflow a little bit. You'll see these in over-the-range microwaves. These will recirculate as well as be able to be ducted to the outside. The filters, again, are going to be there to collect the grease. The problem with the over-the-range microwave, if you remember the earlier slides about how we really want to cover the front burners, they really are ineffective on the front burners because none of them sit far enough out. They'll cover the back burners, but usually never the front. So anything we're cooking up there is going to get in the room. Now they are convenient, answers the question, where do I put my microwave? But as ventilation, it's not really their strong point. And again, they are using filters. The ones in the upper left here, which you'll frequently see in there. The downdrafts also are using filters. They're going to have filters back behind. In the upper one, you see Thermador. It's going to pull everything through that channel at the front. But if you pull that front panel off, down below, you're going to find filters. And again, they're there to try to pull some of that grease out of the cooking vapors that get down and move through them. The other thing with downdrafts is, for years, the lowest CFM you could get them in is 600, because that's a minimum amount you need of air you need to be able to move to redirect the cooking vapors. They've also gotten taller, which is nice, which that helps quite a bit. But now they're also offering them, because there are CFM restrictions across the country at levels that I just don't think are really going to be able to do what the downdraft is trying to do. It's very, very hard to do when everything is working great. Start lowering the CFM and you kind of end up with a backsplash that disappears, that's made out of stainless, that makes noise and maybe has lights on it. So those, you want to keep the CFM up if they're going to have a chance at doing their job. Here are baffle filters, and this happens to be a Pro style liner. A lot of people like the baffle filters because they look cool, because they look very professional, like in that commercial kitchen. And here you can see them. There's that picture I had in the bottom right before, and here's up the top is actually a commercial system. You can tell that because it has the fire suppression in it. Bottom left is a in-home Pro style range insert with the baffle filters, just kind of showing how they come out. The way they work, it's really the same idea as a filter. The notion is the grease-laden air is going to have to make a couple of turns to get from one side of the baffle to the other. Now, the problem with this is if your hood is on low and it's not moving the air very fast, it doesn't move fast enough for any of that grease to get taken out of the airstream. And it just kind of meanders right through along with the air and continues up and goes where whatever's behind it. Predominantly, there's going to be a blower right there and then into the ductwork. Where noise comes from in most hoods, especially baffle style hoods, is going to be when that air changes direction. And that's what generates the noise. So once you start moving the air fast enough to pull the grease out, these do get very, very loud. I recommend if you ever have a chance, if you want to know how they sound, I'll hit sound a little bit, but if you go to a spot like a retailer or something that has any live hoods, just turn them on and decide how loud you think they are. I think sound is very subjective, but most of these on high are going to be loud. And I talked about what's behind there. Unless the blower is remote mounted or an inline blower, the motors most often are going to be right behind the filter bank, which is just how most of them do it. Now, here's an example of a hood that got cleaned very nicely. They did a good job. They cleaned out the filters, spanky clean. They wiped off and cleaned up all the perimeter. But behind it is where a lot of the grease goes, because the filters just can't get it all, and whatever's behind them is going to get laden with grease. So really, you can't get in and clean the blower. There's some you can take apart a little bit, but to be honest, most people aren't going to do that. The other thing is you want to have a lot of Band-Aids on hand, because once you get up there, there's a lot of sharp metal, because they don't tend to finish those off very well, because they're not really intended to be cleaned, but you can see what gets behind there. The pro with hoods with filters is, and I didn't put this in the pros, but your selection is almost endless. Again, almost every hood manufacturer out there is using filters. So you're going to see a lot there. The filters can just go in the dishwasher. There's less surface area around the hood to be cleaned, as opposed to something that might have a big capture area with a bigger bucket that's more open. And especially with the baffle filters, a lot of the drive for wanting those is their appearance. They look very pro. Now on the con side, they're not really super efficient at removing grease. There's in ventilation, they don't do a lot of studies because most people don't think about it that hard. But when they do, they're really getting at best about 70% of the grease that gets up there. And as they do the job, especially a filter, not so much baffle, but standard filters, they're going to reduce that efficiency really quickly. Also, once you put filters in front of a blower, whether it be remote or right there, you're going to restrict the air movement. So it's going to reduce your CFM, and it's also going to generate more noise, because that's where it really comes from. When that air starts moving at the higher fan speeds, it's going to cause quite a roar, to the point, and that's why I say turn them on. If you do that, think about what you're hearing, and you really don't hear at high motor noise. What you hear is that air changing direction at a super high speed. Now, I mentioned earlier there's one manufacturer, Ventahood, who does a completely different approach. They don't use filters. Their blower system is a centrifuge. So they don't restrict the airflow with filters. And the idea is they sit up inside an open canopy. So of all the air that gets pulled through this blower, it's rotating at a speed that generates 300 cubic feet per minute. But more important than that, it's engineered within this box to create pressure. So it pulls all of the grease particles out of the airstream. So by the time they go up and down the duct run, pretty much all of the grease is out of there. In fact, it's like 99.8% is removed from the airstream. Now we do have to get the grease there. So if the hood is too high or too small, or if there's one blower and it's over a $15,000 48-inch range, it can only do so much. So everything else has to be right as well. But this takes a completely different approach to removing the grease from the airstream. And here, an example of what that is that I've always appreciated, very visual, regardless of what kind of hood you're working with. This is where they took a double blower system. On the upper left, it's rated at 600 CFM. They just grilled 6 hamburgers. So again, depending on what kind of cooking you do, but if you grill 6 hamburgers, this is about how much grease you're generating and throwing up into the air. So the contaminants that are going in that you're trying to deal with is quite significant. And that's just 6 hamburgers. Now, if you don't cook hamburgers a lot in the house, or you don't want to, yeah, if you're vegan, you're not going to have as much of an issue. But to give you an idea of what we're capable of producing in a kitchen, this is part of the problem we're trying to solve with good ventilation. So that's a lot about canopies and filters, but let's talk about blowers, because especially in our region, air movement is a thing. We're in Minneapolis and Rochester are 2 of the most difficult places in the country to provide proper kitchen ventilation without a high cost. Simply, what are they? The blowers are what moves the air. It's basically an enclosed fan. And what we talk about with blowers is CFM. That stands for cubic feet per minute. Now, bear in mind, this is volume. So it's not necessarily speed. It doesn't mean the speed of air moving. It's just how much volume you can move in a minute. Now, most blowers are going to do that by changing the speed of the blower, but there are other ways to do it as well. And when they rate blowers, bear this in mind, thinking back to filters that restrict the air movement, CFM ratings are determined with no resistance on the blower. So it's as if you run the blower on a table in the middle of a room. How many cubic feet per minute is it capable of moving through itself? So let's say it's capable of moving 450 CFM. When I put a bank of filters in front of that and put it in a canopy behind those filters, I'm going to reduce that CFM. It might reduce it by as much as 150 CFM out of the gate. So even though it's rated at 450, it might only be moving 300. And how did those blowers move the air? How are they controlled? There's a couple different ways. Some of them are simple on and off. They have one speed. They're just either on or they're off. Many of them are going to have multiple speeds, and it may be kind of like a clicker that'll have a speed 1, 2, 3, 4, maybe 5, 6. Some of them will act like a rheostat, like a dimmer switch on a light. So from its slowest setting to its highest, as you turn the dial up, it will speed up and slow down incrementally based on where you dial the switch. And newer, starting to see this in some of the more smart appliances, there'll be Bluetooth controls where you can maybe control from your phone, which I know we all want to do. I mean, I would love nothing more than sit in my office and turn my hood on. But also it allows in some brands, I think Dacor does this, where their range will actually talk to their hood. So they'll be interconnected and they'll use Bluetooth to do that and set the speed of the blower. And again, let's think back. We want to remove all these things: heat, steam, smoke, odor, get. We want those out of the house. Very important when I work with people who are working with appliances on the front lines at either a retailer or builder supplier. Number one question I make sure they always ask is, can you vent to the outside? Because that starts the conversation in 1 to 2 directions quickly. We can't remove this stuff if we can't vent to the outside. Even if we can't, we will be able to get some grease. Again, that's what the filters are there for. So let's talk about that, ducted or recirculating. Again, recirculating or ductless, we're really only going to be able to deal with the grease. There are carbon filters that can go behind the filter bank that will purport to take care of some of the odor, but the heat's going to come right back in the room. We really can't get rid of it. We're just going to move it around. They're aptly named recirculating. So we want to duct them to the outside. That's the best thing to do. And we want that duct run as short and straight as possible. So here's just an example of what we probably see a lot. You see this with over-the-range microwaves and under cabinet hoods, where it'll go out the top and right out the back wall. There are also external blowers, remote, Sometimes those will go on the roof, on the wall. Now, frequently they are put there, or people want to do this because they want to reduce the noise level. Now, if you think back to what I was talking about when air changes direction, even if you have a remote blower on a Pro baffle hood, once that blower gets up to high, it's still going to be loud. You are removing the motor noise a bit, and some people will say that they think it makes a big difference. I've been in front of both. I don't notice a huge difference because traditionally you don't hear much motor noise. Again, it's the air moving that you hear. The other thing is, in our climate, it's problematic because if something does go wrong with the blower, it's on the roof. Usually, if you're going to need it serviced, somebody will have to go up, take it down for the servicer to work out, and then go back up and reinstall it. Also, when you're installing them, this requires quite a bit more. We're running electrical all the way up to that back and forth through the hood, et cetera, et cetera. So there are complications to that. I personally think the benefits do not outweigh the problems and the issues, especially up in our climate. There are inline blowers that have made an appearance in recent years, and literally, as you can see here, that's what they do. They will install in the attic, in the rafters somewhere, and they actually are kind of a push me, pull me. So they're going to pull in from the hood and then project out to the exterior of the home. And the intent here is to move the motor noise further away from the cooking area. And again, though, when we're on high, we're still going to have a lot of noise on a hood. In general, if you don't hear the hood, it's not doing much, especially if you're cooking, you want to get the grease out of the airstream. You really, if you're not hearing it, it's good for maybe taking, some hoods will run very quiet and low. That's good for simmering something, a little bit of steam, maybe sneaking a heater in the house, but to get effective ventilation, you're gonna have to turn it up, and it's gonna be noisy no matter what. So it brings us to the CFM conversation. How much air do I really need to move? Talked about a lot in Minnesota, for sure. And if somebody goes out to look out on the internet to figure out how much CFM they need, there's a lot of complicated ways to figure it out. As you can see here, and I just pulled this off of a website, kind of thinking like a consumer. They're trying to figure it out on their own. What are they going to see? What I have highlighted here, and I'll touch on this a little bit further in a little bit, it's really easy with gas because everybody agrees that for the most part, for every 10,000 BTUs a piece of equipment is capable of producing, you should have 100 CFM to offset it. So you can see here they did that math. So 40,000 BTUs, we should have at least 400 CFM or more to be able to handle that problem. And here's that just a little bit more specifically illustrated. That on gas, it's pretty easy to do that. Now, I mentioned induction earlier. One thing we do like about induction, we get a lot of the performance experience you get with gas. In other words, the immediate response and things like that. But we're not generating a lot of this ancillary heat that does come off of gas cooking equipment to deal with. That's again why you're seeing it more commercial applications. Their ventilation, for the most part, is there not so much with grease in mind, but to take all the heat away, because traditionally those have been gas-powered equipment without a lot of insulation, so a lot of heat in the commercial kitchen. So I always start with, easiest spot is what is the cooking equipment? A drop-in cooktop is going to have significantly different requirements for ventilation than a professional style range. If I look at a set of plans, in my nirvana, when a plan is laid out and there's a 48-inch rectangle for the cooking equipment, I know I'm going to need a lot of ventilation. And if I'm advising, put makeup air in the bid right out of the gate, because it's going to be easier to take it out than to put it in later. And at 48 inches, no matter what that is, what you should have to be able to work properly is going to be pretty high CFM. Now with electric cooktop, something like that, that's going to require less. 30-inch ranges. It's a little different today than it was 15 years ago. Gas products, even in 30-inch ranges, are now pumping out a lot of BTUs. So induction electric makes it a little bit easier to deal with. And then there, of course, the professional cooktops and range tops, really the same issue as you would have with the big range, as far as the ventilation and the amount of cooking contaminants they're going to be capable of putting out. You can look at the manufacturers of the cooking equipment. They frequently do have their own recommendations, and there's a good reason for this. Now, bear in mind, the rest of the country putting a 1200 CFM hood in is not a big deal. They're not dealing with the ancillary makeup air issues that we have to deal with here. Again, I'll hit makeup air in a minute here, but you know, for customers to expect, if your range should have 1200 CFM and you put 300 CFM over it, just that number difference alone tells you that's way different. That delta is pretty huge, and the performance of that hood is going to be compromised quite a bit. Are you going to be using all the burners on your range? No, but when everybody's over at the house, like on Thanksgiving or Christmas, is that the day you want your smoke alarms to go off? Let's deal with that day and make everything work for that day. All the rest of the year are going to be covered. But to get guidance on that, you can look at what the cooking manufacturers recommend. Now, Wolf, I noticed recently changed, and sometimes they very nebulously just say, yeah, we recommend you use a hood. They're not getting into the weeds of recommending CFM because they found that to be a barrier. It's probably because they're in Wisconsin, so they hit that. Real bare bones way to think about it is 300 CFM is going to be okay for most electric cooking equipment and maybe some smaller gas, certainly an induction, things like that in a 30 or 36-inch cooktop. Once we move into gas, though, the amount of BTUs that are now being produced, even from a simple Frigidaire range, we're getting up to 52,000 BTUs in those. Really overwhelming for what you frequently see over that, which is the over-the-range microwave. By the numbers, you should have upwards of 600 CFM to be able to properly and effectively vent those. Certainly when you get to a 36-inch piece of cooking equipment, now we're going to be generating enough heat that we're going to need more than even 600. We probably should have 900 to 1,000. Once we're at 48 and 16 up, now we're into the range, because most often those are also going to have a grill or a griddle involved with them. That creates a huge issue. So not only do we want to get that hood the right size, we need the capability for when we're doing our Guy Fieri cooking on there to be able to move that volume out. Was recently at a home, they had an issue. They had a 600 CFM over a 48-inch Wolf with a griddle, and everything was installed correctly, but their cooking style just overwhelmed the hood. 600 was not enough. They really should have had more. I get the extra added expense that kept them at 600. At least they were able to do 600. Cooking style is as or more impactful, though, I think, than even the equipment itself. I could be selling the same piece of equipment to two people, and if their lifestyle is a vegan on one end and a rasher bacon a day on the other end, those are two different cooking styles that are going to create two different levels of problems. So that's going to impact my recommendation on ventilation. Certainly the rasher bacon a day is going to need as much as they can get. Vegan, I'm not creating as much of an issue. Bearing in mind this again, what type of cooking are we doing? If we're doing cooking that is using a lot of grease or a lot of odor, to be fair, if somebody does ethnic cooking like Korean cooking, Indian cooking, something like that, that also generates a lot of fragrance, we really want to be able to capture that and get that out. It may not be as greasy, although frequently it is. Big wok cooking, sure. This we want to be able to handle for them. And let's talk about the elephant in the room, particularly in Minnesota, is makeup air. It's something that we deal with a lot. It adds cost, but it's there for a good reason. Recently, a lot of ventilation manufacturers have started to come out with more and more hoods that are going to be at 400, rated at 400 CFM and under, because of makeup air requirements that are being adopted across the country. This is from 2012. Since then, many more states have been coming online with putting into place what they call the national code, which is what has existed here. And it just basically says if you're over 400 CFM, you need to have a system tied into the hood that will, in essence, crack a window so that you maintain the right pressure in the home when you turn your hood above 400 CFM. Now, Minneapolis area, that for 30 years has been a much lower threshold at 300 CFM and even more stringent requirements. The other thing that's unique about our region is we actually have people in our area who enforce them. They're in place in a lot of states, but they are not enforced. So that's why you see slim pickings when it comes to ventilation at that 300 CFM and under, for example. It's a big deal for us. We live it every day. Most of the country doesn't deal with it. So in the metro area, something I've experienced a lot, this is really generally how it works. Up to 300 CFM, they're not going to require you to do anything with makeup air. More and more, just over 300 CFM, it actually is required. But I've seen some inspectors allow no additional makeup air up to 600 CFM. But once we're over that, it's been required in pretty much every scenario I've seen, unless it's some really small town in outer Minnesota where they just don't deal with it. This is more for salespeople who are working with customers at a builder, supplier, or retail. Clients will frequently push them to tell the client how much makeup air they're going to need. If you work with building homes, as you guys do, you know that that's really, you're tied into the city inspector and what they're going to require you to do based on their interpretation on the state requirements and guidelines. And this is Hennepin County. I put this in for a lot of people just to understand how complex it can get, because it can get pretty complex to figure out how to do it correctly. This is an old worksheet basically pointing out that in some of the older homes, if you do the work and you're not putting in new windows or anything, they may actually not need makeup air. However, I do know this for sure. Most of the inspectors will require it anyway in an older home, because their position is down the road, if somebody buys the house and decides to put in new windows and re-insulate and tighten up the home, we're going to make you put in makeup air for the person in the future we don't even know exists yet. So it gets put in place a lot. And what is that? These are some makeup air solutions. The bottom one left is obviously the most basic and not at all automated, but essentially that's what you're doing when you require makeup air. When the pressure changes in the house, you have to be able to pull in air to replace the air you're moving out. A cracked window will do it. I've been in homes years ago where that happened. The hood wasn't drying. We're trying to figure it out. We have somebody crack a window while it's running, all of a sudden it works fine. The house was under negative pressure. Top left is a commercial unit. Top right is something that they do get to use in the rest of the country a lot. It's still a mechanical system, and I'll show you how that works in a second, that's tied to the hood, but it just pulls outside air and just raw. Bottom right is what inspectors want us to do in Minnesota, and to be honest, rightly so. It's a tempered makeup air system. So I mentioned the one that they get to do in the rest of the country we don't get to do very often here. This is basically automatically cracking a window. So it's a system that as soon as you go over the 300 CFM threshold, for example, it automatically tells this blower system to open and allow outside air in to the room that the cooking equipment is in, and it will offset the air that's being brought off. Now, the problem for our areas, again, it's raw cold air. If it's coming in from outside, it's 20 below, that's what it's bringing in. We want to temper that here. So what they're going to do is they're going to require makeup air that's going to temper it. It's very expensive, but if it's a new home and you plan for it ahead of time, it's not as big of a deal as later. Later, it's very much a pain because you need more electrical. You need to find a 10-inch hole for the house. I mean, it can be problematic. I think if you're working on a home that has, again, that 48-inch spot in the kitchen, bid it with the makeup air in already. And if things change, you can take it out. It allows you to, and then you can advertise that you're a really smart person who does things correctly. That's why you might be more than the competitors across the way who aren't doing it the right way. And they do get expensive. I can see where it easily can get to $5,000, but we don't want this to happen. That's what we're trying to avoid. Hit ducting real quick. That is a bugaboo a lot of the time. This is what we want: straight and short as possible. Heat tape, really short. Air is dumb. You got to tell it exactly what to do. Here's some yeses and some nos. Flexible ductwork is easy to work with, but it's bad. It's negative. It's like putting, it's like if you put speed bumps on the freeway. You also don't want dead ends like in the bottom right. You want to keep them smooth and straight and properly sized. If you're supposed to have an 8-inch round and the HVAC guys only have 6-inch, that's a 53% reduction in the airflow. You've just negated most of what's going to be able to happen. So it's really important that the duct run diameter reflects what the blower needs. And also, you can't just do whatever you want. I think anybody can look at these and go, all right, that's not going to work. Very clever, took a lot of work to do this, but you can see in the right and the left, they reduced it and they used the flex ductwork. I go into homes and see this. Why is the hood not working? Everything's fine. I see this. I go, that's your problem. You've choked it down so much it can't work correctly. So you want it like this. You want it really straight. So if you're in the end of designing, think about where the cooking equipment's going to go and think about where it's going to go out of the house so that you can duct it properly and easily. Island hoods are tricky. Again, you do have to, they're going to hang from the ceiling. They have to be able to connect to what's up there. Adds a layer of complexity to how you're going to locate them and where they're going to go. But even if people go and look at how to install them on the internet, they find really bad advice. I mean, this is stuff when I looked for, how do you properly install a hood? They showed this, and none of this is correct. All of this is going to severely compromise how well the hood's going to be able to work. So form versus function. What do we have going on? Most customers, when they're picking it out, they go by aesthetics. They rarely think about how well it's going to work or noise. But when they have complaints, it's usually it's too loud, it doesn't work. They rate them on zones instead of decibels. This is kind of how that works out. End story is most hoods on high, especially pro style hoods at 1,000 to 1,200 CFM, are so loud you really can't talk in front of them. There's only one out there that at high you can do that in front of, and it's moving volume, but it doesn't move it fast, so it reduces the amount of noise that you get. Noise is really impactful to people. So again, back to this, selection of the equipment of ventilation is just as important, or I would say more important than the cooking equipment itself. One of the big things when you're advising them on what to do is you can start with what I talked about, which is the equipment. That will tell us something. But what is their lifestyle? I mean, are they the vegan? Are they doing a rasher bacon a day? Is it pro? Are they going to go Guy Fieri? If you're going to do that because it's your dream house, I want to provide them proper ventilation, even if I have to put in makeup air. If they have caterers who come in, you can offset it for that. I mean, what do the caterers tell you want to do? But there's also a lot, it just doesn't matter at all. I get that. They're just going to order out. Grubhub. Makeup air, you do have to consider. I mean, we're dealing with this. We want to be able to get this out. But if we have to put in tempered makeup air, it does add to the cost. Now, a big expensive home, percentage-wise, it's probably not as much. Again, I would encourage you to plan for it ahead of time, because planning for it on the other end, I'm sure you've seen this, is problematic for a lot of reasons. But when you undersize it, this is basically what you're asking the hood to be able to do. An analogy I like to use is this. It'd be like, because people say, oh, I don't cook with all the burners on, only a couple times a year. Well, if you bought a truck because you're going to haul a boat 2 times a year, but it costs $5,000 more to get the equipment that would be able to handle the boat. Oh, and by the way, because it's only going to be a 4-banger, it's going to struggle over 70. And you go, well, I'm only going to need to tow my boat 2 times a year, and I really don't drive that fast, so I'll be fine with the V4. You know, it's those 2 days a year. If your truck can handle that, you're going to be fine with everything else. Cooking equipment is a lot like that, because we don't want this to happen. The left is a real world thing I went to. Their concern was they didn't think their hood was vented right. It's 300 CFM. The designer made it too small because it looked better. And the end result in their $400,000 remodel over their $15,000 range is their smoke alarms go off every time they cook on more than 2 burners. So I want to help people get to the point where they understand what's going on. If they choose this, they're going to know ahead of time and they won't call and complain because they knew they undersized everything. But to give them the option of doing it correctly is huge because we don't want this to happen in their house. We really want to try to avoid that. Pretty soon, there may be requirements that will disallow us from making bad decisions. And bearing in mind that this is something nobody ever said. They don't expect it. They haven't experienced it before, but we can get them there if we do it right. This is a saying that I do like, that especially with ventilation, design isn't just what it looks and feels like, it's how it works. Hoods are very much that way. A lot of them look super cool. These are standard ones, kind of know how well these are going to work, but there's some funky stuff out there. You can look at these, you know, the one upper left, I think Red Green did that one. But a lot of these look really cool, but when you understand how ventilation works, they're just not going to be able to function very well, although they look awesome. So we're dealing with all this stuff and trying to get that out, but bringing it together, we've got how they look. We want to get them in the right spot. Can you direct it to the outside? Get the hood installed correctly based on how it's engineered to work. What are we putting it over? What's their lifestyle? How are they going to cook? How important is air quality to them? I think it's getting more important for everybody. And then their expectations. I do a lot of aligning them. People don't understand their hood can work properly, but you can get them to a spot where they can go, well, the hood that will work properly in your home is going to cost X amount, and we're going to have to spend an extra $5,000 for the makeup air to make it work correctly. They can make that decision then. You know, what is it on their mortgage? $5,000 more in their $800,000 home. If you can physically get it in there, let them make that decision. And then if they say, oh, we don't want to spend that, then at least you can say, okay, well, you know, it's not going to keep up. You might have the smoke alarms go off once in a while, but not often. If you're cool with that, we're good. And then it's their call. So hopefully I helped you guys get here a little bit. What, you know, basically ventilation, what is it? How you expect different ones to work when you even just look at them. This is big. Where the hood is and how it's installed is huge. And the positive impact to me, if you do it correctly, that it can have on not only the kitchen, but if it's a new home or a remodel, how much they enjoy the whole thing. 3 years out, are they loving it, or are they going, God dang it, that smoke alarm went off again? I wish we'd spent the extra money to do it right. You know, you want to get them to the right spot. Hopefully that all helped. Thank you for the time. I really appreciate it. And let me know if there are any questions. Anytime you need help, it doesn't matter what it is around ventilation. I'm here to help everybody. I do it a lot. It doesn't matter what the issue is. I have products I have access to, but if it's something I don't, but I know what it is, I'll always tell somebody the right spot to go. So again, thank you for your time, and stay safe, and let's hope we all get back to normal soon. Thank you.
Thank you, Michael. Appreciate your time today. And let's see here. There is a question. Oh, the comment. Thank you. That was great.
Sure.
So appreciate your time, Michael, and very informative. And you stay safe out there too.
All right. Thanks, everybody. Appreciate you.
Thank you.
Thanks, John. Bye-bye.
Bye-bye.